Hey everybody, welcome to today's community webinar where we are going to be delving into the world of CSI, Container Storage Interface. My name is Randy Arsenault, and I'm joined today by JC Lopez, who is our deep domain subject matter expert on all things container native storage, including CSI. JC's been doing this for many years and has a ton of experience and expertise that he's going to bring to bear. So before we dive in and I hand it over to JC, I want to just kind of set the stage real quickly and talk a little bit about what the purpose of today's session is. So I want to introduce kind of an idea about CSI. For those who don't know, again, JC is going to go into a lot of detail about what CSI is and why it's relevant. It is a great way if you're developing stateful apps with Kubernetes and you need persistent data. It's a really good way to start developing and deploying those apps. And it also sets kind of a foundation and paves the way for even more sophisticated cloud native data services like, things like metro and regional disaster recovery, application aware backup and recovery, automated discovery, caching, and just some more sophisticated data services that are available in, for example, Fusion, which is our fully featured cloud native storage platform, IBM Storage Fusion. So without further ado, I'm going to hand it over to JC to take us through the content. And please, if you have any questions, feel free to enter them in the Q&A panel and we can grab them as we go. So JC, over to you.
Thanks, Randy. Hi, everyone. Probably morning, afternoon, evening, different places. So let's cover it all. I put together a few slides to cover this very interesting topic. So just like build a little agenda, an intro about, just what it is, a little CSI overview, the pre-CSI era that I call the dinosaur era, introduction of CSI, the evolution of CSI, the different developments and enhancements that we saw in CSI, and that's very important so that we can see how things have moved. And the current state and adoption, which is always interesting, and we can discuss a little bit what is the strategy of people moving to orchestration platforms. And finally, a conclusion. Just as a mark, and I say that right now, I added a few slides after the closing slide for people that are more interested in the architecture, how things are built and how things are chained, technically speaking, so that you can have it. I think it's like 4 slides, but this way you have a reference that you can go back to. So let's get started. So storage management in containerized environment. So what are Kubernetes CSI drivers? CSI stands for Container Storage Interface. And it's the idea that you can satisfy persistent storage needs for containers and allow every single storage provider to easily ship, fix, but also enhance whatever they want to provide the end user with. So why are those drivers important? Is that Kubernetes is the container orchestration platform, but it is only a container orchestration platform. So from the beginning and the very early days, basically storage was kind of a leftover, let's put it this way, and it focused exclusively on pods and containers. So CSI was a way to provide the ability to expand what Kubernetes could do in a very flexible way. And we're going to see in the next few slides in an asynchronous way, because in the beginning, that's not the way it was. So if you look at the developer perspective, you look at the application today, has nothing to do with the way the applications used to be. Containerized, we have the concept of microservices. You hear very often the term modernization. And these are, the real way that applications are coming to life today. And every single company has like either a project or a strategy on how to move to this new way of doing and deploying application. Now, Kubernetes was designed as a self-service platform. So basically, you have to link the two together. So you need to find new ways that requires the flexibility and the on-demand for anything Kubernetes. And that's the very important part. If you think about a developer when he creates an application, he's going to do his build, he's going to build his container image, and then he's going to deploy the app, all of that by himself. when he does the development cycle. This is going to move to QA. QA is going to go the exact same way. And then it moves to production and it's going to be the exact same way. Just like everything like happens on demand. So now you need to find a solution so that even the storage part follows the exact same concept where when you need storage, well, you just get storage. So to just like give a brief overview about CSI, so it's a standardized interface between the container orchestration platform, that's Kubernetes. In the case of IBM, we love to talk about Red Hat OpenShift. Red Hat OpenShift uses Kubernetes as a container engine, and the storage system that you want to access to provide some storage to do something. So it allows the integration and the management of the storage solution from inside the Kubernetes environment. And that's the important part. Remember everything Kubernetes, everything like self-serving. Basically, we want to do the same with storage. So the benefits of CSI, and by standardizing on CSI, it allowed the storage providers to basically abstract the storage complexity and what I call the obscure nature of storage. You've all heard different storage vendors, they use their own terms, sometimes to describe the same feature or set of features. And you require an infrastructure team to manage these storage infrastructures. So that doesn't really fit into the world of Kubernetes. You want things to be completely self-service, so you cannot really wait for someone in the storage team to do something so that the application can actually get it. So it provides the users with what I call the keys to the car. You need 1 terabyte, you need 1 gigabyte, you need 100 megabytes, you need some features, snapshots, clones, backup, restore, whatever. Basically, the user decides what features he wants to use. And that includes, and that's just a short list of what you may potentially need as a user: provision some storage, delete some storage, attach some storage, detach, snapshot, clone, backup, or restore. Now, what is important with CSI is that it completely decouples the storage layers from Kubernetes. So basically, you have a set of drivers, and the CSI drivers are now actually separate from the Kubernetes code itself, which is very important because we'll see in the pre-CSI era how things work. So this way, each to his own, the features you want, the problems you bump into that come with a specific CSI driver or storage platform, but also the enhancements that can be provided to you by the storage provider. So here is what I call the archaeology slide. Randy added a very nice little dinosaur image on this slide, and I think it's really cute. And the first, if we look at the challenges of this pre-CSI era, so first of all, there was no standard interface. So everyone was doing his own stuff in his own way in what we call in-tree drivers. And that really, really favored lock-in situations because a storage provider would have his own driver and you would kind of be stuck because that's the driver you started using. You could not find an easy way to have the same features somewhere else. So each storage provider implementing their own features and their own thing, but had nothing in common with other guys. So it made the container adoption more difficult, specifically for stateful applications. Stateless applications are a different world, so we won't talk about these guys here. So the limitations, because of these challenges, that you had limited flexibility. Upgrades or updates were scary, let's put it this way. And because the drivers were in tree, so basically shipped with a Kubernetes code, the version of the driver you would be using would be linked to a specific Kubernetes version. So that created a hard link between the Kubernetes version and the actual features you wanted in the storage. So not very flexible for sure. And more important, when you had to use or do updates or do upgrades, you would kind of had to work on eggshells, because when you wanted to upgrade or update, well, very often things would be a little bit complicated. Day two operations could be like kind of a nightmare, and you were kind of trapped in Kubernetes version storage layer that you wanted to use. So then came CSI, and the Kubernetes community get together with the storage providers. Very important. All of the storage providers had their say in this conversation, and everybody recognized that because of the need to be able for Kubernetes to host stateful application, there was a need to have a standard interface that everyone would follow to just like take care of the challenges and the limitations that were identified when we were using entry drivers. And more important, when you think as a group of work, basically that got together, it was really, wow, Kubernetes is great for stateless, but because we are so limited and so strictly bound to the Kubernetes entry drivers, it doesn't favor the adoption beyond stateless application, which were an easy first play, obviously, because storage was not really a concern for stateless applications. So all storage providers collaborated. The CSI work group defined like a set of common services that were extensible, so that in the future, based on that core concept, we would be able to add more features. But very important, every single storage provider would have like the same playground or the same level of play to actually bring the features. So a unified approach for all of the requirements that were put together, and we'll see that the original ones were extremely limited. So put the emphasis on the community-driven nature of CSI, very important. About every single vendor, or I would say probably 80% of the vendors, make their CSI drivers open source and community-driven. It's easier, you get more feedback, you can fix bugs faster, you can actually have ideas for new features in a better way. And it facilitates the integration of stateful applications in a containerized environment. So something that probably most of you do know, with CSI, we introduced like some features such as storage class parameters that can actually specify who is the driver, what is the driver that you want to use for a specific storage class, and that's just like a CSI storage class. So the evolution of the CSI drivers, originally introduced in Kubernetes 1.9. So I think the latest one is 125, and you can correct me, Randy, it's either 124 or 125, I think. We're around that. So the storage providers were just like the CSI drivers of that time were minimal. It was basically provision, delete, attach, and detach. That's basically the most common operations. And every single provider was able to migrate from the entry drivers to the CSI drivers because it provided more flexibility. But the cool way and the cool thing about CSI is that now, because of this common interface, everyone could work at its own pace, at its own features, and that really enabled the fast adoption of those drivers. And, obviously, because stateful applications need all of the enterprise-grade stuff that we know of, the snapshots, the clones, whatever, everybody worked on its own driver to add all of these features. So one of the key things behind CSI is that it allowed an easier way to port applications from one environment to another. Now, when you have an application, they say, I need a capacity and I need these features. I'm using this storage class with this CSI driver. Now you can actually shop around or identify maybe a better CSI driver that provides the same capability, but let's say maybe better performance, for some reasons. So portability of applications become like something that you could actually touch with your own hand. So because of these features and because of these standardization, stateful applications could now enjoy like a real place, a real enterprise grade environment, rather than always a kind of crawling rather than walking. Now stateful applications have all of these standard features in Kubernetes environment. So now it makes sense to be able to bring an application in a containerized environment because it's going to be able to benefit of the same features that you used to have on like standalone servers, such as, the capacity, the performance, the backup, the restore, the snapshot, the clone. So there's no really a way to say, well, I can't move my app to a containerized environment because I don't have all of the features that I need for my stateful application. So that really democratized the self-service way of Kubernetes, but for storage. I want my capacity. I want the stuff that I need in my app. You let the developer write his stuff, and then you go down through QA to production with all the standard features and all of the things that you need. So development and enhancements, as mentioned, in the early days, attach, provision, delete, attach, and detach. That's basically about the only 4 features that you had in the original CSI. Now, what was added after that, and that's just a little list. We have more stuff coming around. So snapshots were added, clones were added, volume resize was added. Believe it or not, the original CSI interface standardization did not say anything about volume resizing. So even volume resizing had to be like standardized. At-rest encryption, performance, so that you can actually, depending on what you do, you can pass extra parameters to your CSI driver so that you can actually alter the behavior of the CSI driver to favor performance, for example. We also have like option that supports discard features for some CSI drivers. So you add a parameter, say, every time I delete something on a file system in a container, rather than simply just like deleting and not talking to the storage backend, I want the driver to ask the storage backend to reclaim the space in case the space has become totally unused. Deduplication, compression, disaster recovery, backup and restore. That's some of the few things that we have in here together, and way, way more features to come. A note on disaster recovery. Remember, I said originally the first candidate for containerized environment were stateless application, but because of the surge in bringing stateful applications, because we have a lot of stateful applications in the enterprise world, a need came to life, right? When you have a stateless container native application, disaster recovery is kind of a walk in the park, right? When you have a stateful application, you have a volume that contains the state of the application. So the state of the application is actually stored on a physical volume. So how do you do disaster recovery? Because now you know that you need to replicate the actual state that is in this volume to somewhere else. So then comes the notion of supporting what we call metro disaster recovery, so that you have like 2 clusters that are close to each other. And it's, the latency allows you to do a synchronous replication, or you have regional disaster recovery because your 2 clusters are so far apart that you cannot do synchronous mirroring. So you need to find a way to push the data to the other side, but not be bothered by the latency. So in that case, the RPO, recovery point objective, will likely not be 0 because you are doing asynchronous, mirroring, and you're going to try to get an RTO that is going to be as low as possible, even if you do regional disaster recovery. So state and adoption. About every single storage provider have a CSI drivers these days. I know of one exception that I will not name. That's not the purpose of this call. They used to have a CSI driver, but they actually withdrew their CSI driver from being publicly available. But when you think about all of the major brands, everybody has a CSI driver. Users, why do they like those CSI drivers? Is that it completely fits the self-service concept. Well, I need storage. Okay, I get the storage. And what is very nice is that you can actually have multiple CSI drivers in a single cluster. So you can have, I want access to very slow storage because it's for my developers. I don't care if I give them like slow storage. But I also want to test the app when they develop with something a little bit faster so that we're closer to what the real life in production will be. So you can actually mix CSI drivers in a single cluster. And again, it's just easy. It's just a storage class you change in the application CR, custom resource, and your apps, redeploys with the correct storage class. So many storage providers, remember when we were talking about community-driven for CSI, many storage providers have open source CSI drivers for more portability. As you all know, there are different flavors of the Kubernetes environment, and what we call vanilla Kubernetes, which is like a plain and standard upstream Kubernetes cluster. But Red Hat OpenShift also, uses Kubernetes under the hood. So you can actually get your code, assemble your CSI driver, and make it available either for a standard Kubernetes driver, vanilla Kubernetes, or an OpenShift environment. Very interesting. Most of the cloud providers who were originally not CSI compliant, I'm going to take an example, which is EBS, for example, in AWS. AWS EBS driver was not a CSI driver. So even the cloud providers such as AWS and others like Microsoft Azure and Google Cloud, everybody's moving to CSI because it makes more sense. They want to have if you put yourself in the shoes of a cloud provider, you want to isolate yourself from the Kubernetes source tree. So it makes more sense to have a CSI driver so that whatever the Kubernetes version, right? Okay, sure enough, you have to validate your driver, but your driver itself is no longer in that Kubernetes tree, so that when you upgrade the Kubernetes version, your CSI driver remains the same. You have better control for support of what you do and what you provide your end users with. So there is a CSI developer framework, and it's open source, so that anyone that wanted to try to write a CSI driver can actually do so. And one of the best example, most commonly used open source CSI driver that a lot of developers do use, there is an open source NFS CSI driver. So its capabilities are limited, but it allows you to access an NFS server to provide some storage. And it's just like, it's on a GitHub, publicly available, and you can play with that. So even if you don't have like storage in your environment, you can make it very simple, even for yourself. When you want to write like a little demo application, you can actually use that. So the wide adoption drive end users, because they're now being able to choose the best solution for their needs. Remember, we said you can mix CSI drivers in a cluster, so that makes everyone's life easier. Life easier for the infrastructure team. You can provide different SLAs, for example, and life easier for the developer that can choose the feature that he wants for the application he's creating. We also saw the migration tooling that started to appear. So more and more, one of the questions is, how do I move my application from this environment to this environment? So we started seeing those, toolkits appear to make life easier from a company perspective. And finally, a note on the adoption. Remember, CSI started with 1.9 and it GA'd actually in 1.13. So as a conclusion, what I would say, addressing the challenges and the limitations of storage for stateful application, that's what CSI was designed to do. It is doing a great job, and it's still work in progress. Like most of the stuff we do in this world, we're still at the beginning of the journey. So CSI will keep evolving and more features will be coming to CSI. It provided the ease of use that end users needed, whether you're a developer, a QA engineer, or a platform engineer, no difference. You have access to the exact same thing wherever you are. It completely integrates with the self-service concept. That's the most important part. When a developer wants, 1 terabyte, you cannot say, well, send me an email with an ask for 1 terabyte, and in 2 weeks I will tell you, okay, here are your 1 terabyte. You want to make sure that the developer or whoever needs it actually gets the 1 terabyte. So the storage can be internal, what we call container native storage, or can be external. That's what we call container-ready storage, and still leverage the exact same interface. No matter what. And with this, all enhancements will come through the CSI driver, so you can just update the CSI driver to get the new features. Day two operations will be standardized, and everything will be separated. And that makes enhancements easier when it comes to Kubernetes. You are no longer linked to a particular Kubernetes version. So as a one-liner is that CSI makes the future of storage management in Kubernetes brighter every day. That's what I have to say. So hope you enjoy this. And Randy, you're smiling, so it looks like you enjoyed that.
I absolutely enjoyed it, as I always do enjoy your presentations, JC. Great job. So, hopefully this was helpful. I think it really does a good job of explaining, the design ethos behind CSI. And if you think about it, it's an extension of Kubernetes, right? It's about openness. It's about standards-based consistency across platforms and use cases. And, as we said off the top, it's a great way to begin the journey towards stateful applications on Kubernetes. And as it evolves, it will continue to improve. IBM and other vendors, as JC mentioned, support CSI very robustly. We all provide CSI drivers. We have it for our flash system and our DS family of storage devices and others. And of course, with Storage Fusion, we're extending the capabilities even further by providing some kind of more advanced data services around protection and disaster recovery. So, think of, I would advise you kind of think of CSI as a great starting point and a great way to evolve into kind of more sophisticated use cases and tooling with cloud native solutions like IBM Storage Fusion. So that brings us to the end of the session today. Thank you, everyone, for joining. If you have any questions after the fact, please feel free to reach out to any of us, and we will be happy to answer them. Thank you, JC, once again, for your great presentation. And with that, we will close off the session today. Thanks.